Exercises. Question 1. Fill in the blanks. 1. A ray of light parallel to principal axis after reflection from concave mirror passes through dash. The answer is a ray of light parallel to principal axis after reflection from concave mirror passes through focus. Two. The focal length of dash lens is positive. The answer is the focal length of convex lens is positive. 3. The image of an object is formed behind dash in hypermetropia. The answer is the image of an object is formed behind retina in hypermetropia. 4. An optical device used by watch repairers is dash. The answer is an optical device used by watch repairers is convex lens. 5. The power of spectacle for myopic eye is dash. The answer is the power of spectacle for myopic eye is negative. Question 2. Rewrite the following table so as to match second and third column with the first column. Column 1. Myopia, hypermetropia, presbyopia. Column 2. Old age problem, nearsightedness, long-sightedness. Column 3. Convex lens, bifocal lens, concave lens. The answer is myopia is nearsightedness and it can be corrected by a concave lens. Hypermetropia is long-sightedness and it is corrected with the help of a convex lens. Presbyopia is an old age problem. Bifocal lenses are required to correct this vision defect. Question 3. Answer the following. 1. State the different positions of source of light with respect to concave mirror. A. In torches. B. Projector lamps. C. In floodlights. Answer. Torches. The concave mirror is placed behind the bulb inside the torch. The bulb is placed at the focus of the mirror. Projector lamp. The concave mirror is placed behind the projector lamp. The projector lamp is placed at the center, that is, the focus of the concave mirror, so that rays of light falling on the mirror get reflected and become parallel to each other. Thus we get a beam of light coming from the bulb, which can travel a long distance. Floodlight. The concave mirror is placed in front of the bulb so that the light falls on it and spreads in all directions. Second, what are the rules used for drawing ray diagrams for the formation of image by spherical mirror? Answer. Images formed by a spherical mirror can be studied with the help of ray diagrams. A ray diagram is a specialized pictorial representation used to trace the path of a ray of light. For drawing ray diagrams, rules based on laws of reflection are used as mentioned below. Rule 1. If the incident ray is parallel to the principal axis, then the reflected ray passes through the focus. Rule 2. If the incident ray passes through the focus, then the reflected ray becomes parallel to the principal axis. Rule 3. If the incident ray passes through the center of curvature, then the reflected ray traces the same path. Third, what is meant by power of accommodation of eye? Answer. The eye adjusts to various object distances by changing the focal length of the lens. When a nearby object is to be seen, the focal length of the eye lens decreases and the lens becomes thick. Due to this, nearby objects are clearly visible. However, when distant objects are seen, the eye lens becomes thin and the focal length increases. This helps the eye to see distant objects clearly. This ability of the lens of adjusting focal length is known as power of accommodation of eye. Fourth, state the function of iris and ciliary muscles in human eye. Answer. 1. Light enters the eye through cornea. Behind the cornea, there is a dark muscular diaphragm called iris. 2. The color of the iris is different for different people. 3. There is a small opening at the center of the iris called pupil. The pupil is useful to control and regulate the amount of light entering the eye. 4. The iris is opaque to light, hence its function is to prevent light finally entering the eye through all other parts except the pupil. 5. Ciliary muscles are attached to the lens of the eye. When these muscles relax, the focal length of the lens increases. Thus, the ciliary muscles help in adjusting the focal length of the eye lens. Fifth, if you are given a part of hollow spherical glass, how will you convert it into a concave mirror? Answer. To make a mirror, one surface of the glass is silvered to make the surface reflecting. If the inner side of the spherical glass is polished, it becomes a concave mirror. Question 4. Distinguish between first, myopia and hypermetropia. Answer. 1. Myopia defect arises due to slight elongation of the eyeball or due to the bulging of the eyeball, while hypermetropia defect arises due to slight flattening of the eyeball. 2. In myopia, the distance between the eye lens and the retina increases more than the normal eye, while in hypermetropia, the distance between the eye lens and the retina decreases. Second, distinguish between convex mirror and concave mirror. The answer is 1. In convex mirror, the outer surface of the spherical mirror is polished, while in concave mirror, the inner surface of the spherical mirror is polished. 2. A convex mirror is called a diverging mirror, while a concave mirror is called a converging mirror. 3. Incident rays are parallel to the principal axis and diverge after reflection from the convex mirror, while incident rays are parallel to the principal axis and converge after reflection on the concave mirror. 4. In convex mirror, image formed is always virtual and diminished in size irrespective of the position of the object, while in concave mirror, image formed is virtual or real, magnified or diminished in size depending upon the position of the object. 5. Convex mirrors are used in vehicles, while concave mirrors are used in solar furnaces. Question 5. Give reasons. First, you cannot enjoy watching a movie from a very short distance from the screen in a cinema hall. Answer. 1. The eye adjusts to various object distances by changing the focal length of the lens. 2. The focal length of the eye decreases while viewing far objects. 3. The process of focusing eye at different distances is brought about by changing the curvature of the elastic lens. 4. Focal length, however, cannot be decreased below a certain value. 5. The minimum distance for the normal eye at which the objects can be seen clearly and distinctly without any strain on the eye is 25 centimeters. Hence, we cannot enjoy watching a movie from a very short distance from the screen in a cinema hall. Second, a simple microscope is used by watch repairers. Answer. 1. The simple microscope contains a convex lens. When an object is placed between the focal length and optical center of the lens, a magnified virtual and erect image is obtained. 2. By holding the microscope close to the watch, the minute parts of the watch are magnified and easily visible. Hence, a simple microscope is used by watch repairers. Third, a concave lens is used to correct myopia. Answer. 1. A person suffering from myopia cannot see distant objects clearly but can see nearby objects. This is because the image of the distant object is formed in front of the retina. 2. This happens because the distance between the eye lens and retina increases as eyeball is lengthened or lens is curved or ciliary muscles do not relax sufficiently. 3. A concave lens causes light rays to diverge before it strikes the lens of the eye, and hence, after converging action of the eye, the image is formed on the retina. Therefore, concave lens is used to correct myopia. Fourth, in old age, bifocal lens is necessary for some persons. Answer. 1. As ciliary muscles lose the capacity to change the focal length of eye lens, aged people experience eye lens presbyopia. 2. Sometimes they suffer from both myopia and hypermetropia. 3. Myopia needs to be corrected using concave lens. Hypermetropia is corrected using convex lens. Hence, bifocal lens, which consists of both convex and concave lens, is used to correct myopia and hypermetropia. Fifth, concave mirror are used in solar device. 1. When light rays parallel to principal axis fall on a concave mirror, they converge and are concentrated at a particular point. Therefore, to concentrate light rays at a point, concave mirrors are used in solar devices. 2. This not only concentrates the sunlight, but also facilitates heating. 3. Thus, helping the food to get cooked faster in Question 6. Draw well-labeled ray diagrams for image formation by convex lens when 1. Object is at 2F1. Answer the diagram. 2. Object is between F1 and 2F1. Answer. 3. Object is between focus F1 and optical center O. The answer. Question 7. Draw ray diagram for concave mirror when 1. Object is at center of curvature. Answer. 2. Object is at focus. Answer. 3. Object is between center of curvature and focus. Answer. Question 8. Given below is a diagram showing a defect of human eye. 1. Name the defect shown in figure. Answer. This defect is seen in hypermetropia when the image of nearby object is formed behind the retina. 2. Give 2 possible reasons for this defect of eye in human beings. Answer. The 2 reasons for this defect of eye in human beings are as follows. 1. The distance between eye lens and retina decreases on account of either shortening of eyeball or fattening of lens. 2. The focal length of eye lens is too long, or the weak action of the ciliary muscles can cause low converging power of eye lens. Three. Name the type of lens used to correct the eye defect. Answer. Convex lens is used to correct this defect. The reflected rays are made to converge on the retina, so that the image is formed on the retina. Four. Draw a labeled diagram to show how the defect is rectified by using the lens. Answer. Question 9. Fill in the blanks for convex lens. First, focal length f is equal to 0.2 meters. What is power of lens? P is equal to 1 upon f. Substituting the values, P is equal to 1 upon 0.2. So, Power of lens is equal to 5 diopters. 2. P is equal to 2D. What is the focal length? P is equal to 1 upon F. Substituting the values, 2D is equal to 1 upon F. Therefore, F is equal to 1 by 2. Therefore, focal length is equal to 0.5 meters. 3. Focal length F is equal to 0.1 meters. What is the power of the lens? P is equal to 1 upon F. Substituting the values, P is equal to 1 upon 0.1. Therefore, power of the lens P is equal to 10 diopters. First, height of image is equal to minus 30 centimeters. Magnification M is equal to minus 2. What is H1, that is height of the object? Magnification M is equal to H2 upon H1. Substituting the values, minus 2 is equal to minus 30 centimeters upon H1. Therefore, H1 is equal to minus 30 upon minus 2. Therefore, H1, that is height of object, is equal to 15 centimeters. Second, H1 is equal to 5 centimeters. H2 is equal to minus 20 centimeters. What is M? The magnification. M is equal to H2 upon H1. Substituting the values, M is equal to minus 20 upon 5. Therefore, the magnification is equal to minus 4. Third, H1 is equal to 10 centimeters. M is equal to minus 0.5. What is H2, the height of image? M is equal to H2 upon H1. Substituting the values, minus 0.5 is equal to H2 upon 10 centimeters. Therefore, H2 is equal to minus 0.5 into 10. So, height of image H2 is equal to minus 5 centimeters. Question 10. Solve. 1. An object of size 7 centimeters is placed at 25 centimeters in front of a concave mirror of focal length 15 centimeters. At what distance from the mirror should a screen be placed so that we can get a sharp and clear image? Find nature and size of the image. Answer. It is given height of object H1 is equal to 7 centimeters. Object distance U is equal to minus 25 centimeters. Focal length of concave mirror F is equal to minus 15 centimeters. To find A. Size of image H2, B. Nature of image. Solution. 1. 1 upon V image distance plus 1 upon U object distance is equal to 1 upon F focal length. Therefore, 1 upon V is equal to 1 upon F minus 1 upon U. Substituting the values, 1 upon V is equal to 1 upon minus 15 minus 1 upon minus 25, which equals minus 1 upon 15 plus 1 upon 25. Further, minus 5 plus 3 upon 75. Therefore, 1 upon V is equal to minus 2 upon 75. Therefore, V is equal to minus 75 upon 2. So, V, the image distance, is equal to minus 37.5 centimeters. Thus, the image is formed at 37.5 centimeters in front of the mirror. Second, magnification M is equal to H2 upon H1 equal to minus V upon U. Therefore, H2 is equal to minus VH1 upon U. Substituting the values, H2 is equal to minus 37.5 into 1 upon minus 25. Therefore, H2 is equal to minus 10.5 centimeters. Since the image formed is minus 10.5 centimeters in height, it is real, inverted, magnified image and is in front of the mirror at a distance of 37.5 centimeters. 2. An object of height 5 centimeters is held 20 centimeters away from converging lens of focal length 10 centimeters. Find the position, nature, and size of the image formed. Answer. It is given height of object H1 is equal to 5 centimeters. Object distance U is equal to minus 20 centimeters. Focal length of convex lens F is equal to 10 centimeters. To find A, image distance V, B, size of image H2, and C, magnification M. Solution. First, 1 upon F is equal to 1 upon V minus 1 upon U. Therefore, 1 upon V is equal to 1 upon F plus 1 upon U. Therefore, 1 upon V is equal to 1 by 10 plus 1 by minus 20. Therefore, 1 by V is equal to 1 upon 10 minus 1 by 20. 1 upon V is equal to 2 minus 1 upon 20. Further, 1 by V is equal to 1 by 20. Therefore, V is equal to 20 centimeters. The image is formed to the right of the lens at a distance of 20 centimeters. That is, image is formed at 2f2. Second, magnification M is equal to V upon U is equal to H2 upon H1. So, H2 upon H1 is equal to V upon U. Therefore, H2 is equal to V upon U into H1. Therefore, substituting the values, H2 is equal to 20 upon minus 20 into 5. Further, H2 is equal to minus 1 into 5. Therefore, H2 is equal to minus 5 centimeters. Therefore, the image formed is real, inverted, same size of the object, at distance of 20 centimeters on the right side of the lens. 3. An object is placed at a distance of 10 centimeters from a convex lens of focal length 12 centimeters. Find the position and the nature of the image. Answer. It is given object distance U is equal to minus 10 centimeters. Focal length F is equal to 12 centimeters. To find image distance V, nature of image and magnification. First, 1 upon V minus 1 upon U is equal to 1 upon F. Therefore, 1 upon V is equal to 1 upon F plus 1 upon U. Substituting the values, 1 upon V is equal to 1 upon 12 plus 1 upon minus 10. Therefore, 1 upon V is equal to 1 upon 12 minus 1 upon 10. Further, 1 upon V is equal to 5 minus 6 upon 60. 1 upon V is equal to minus 1 upon 60. Therefore, V is equal to minus 60 centimeters. Second, magnification M is equal to V upon U. Substituting the values, M is equal to minus 60 centimeters upon 10 centimeters. So, M is equal to minus 6. Since the magnification is negative, the image is real and inverted and 6 times larger than the object, that is magnified at distance of 60 centimeters.